All right, next we have the dynamic duo of Hamilton Carter and Hammy Carter from Tenet Academy, visualizing NOAA GloTEC data to improve ionospheric communication channels. If you know what that means before they give the talk, you're a better man than I am. All right, come on up, guys. Give them a hand. Yeah.
You got it? Cool. You good? Awesome. Okay, so what we're going to do is show you some apps that we made to visualize point-to-point amateur radio contacts as they go over the horizon. And the way they go over the horizon is the radio waves reflect off of the ionosphere.
And the ionosphere is a layer of the atmosphere that gets ionized when the sun hits it so that radio waves can refract through it. And two important things to know about the ionosphere are the height of the ionosphere at any given point and what frequencies will refract through it.
And so the map here is a QSO map, and you can see there's a QSO that Hammy made going up there, or a contact going from Colorado down to Argentina. And so what we needed to be able to do was map out and visualize what the ionosphere looked like on a global scale, because you're going all the way across the planet, and then be able to also map the QSOs in real time, so you can see the ionosphere evolve as the radio contacts are happening.
And so originally we were doing that with ionosons, but there are not very many of them, and half the time they're turned off. So we needed better data, and we found Cosmic 2. Cosmic 2 is a satellite constellation that measures the ionosphere, and so we took that data, I put it into a comma-separated variable file, I put the comma-separated variable file into a modified QSO map template, and that got us, can you hit this thing?
Yep.
A spire map.
Yep, and so what's going on is each little square you see there is actually a spire. When you zoom in, you can see the spires down here on the bottom. And that was good, but Cosmic 2 misses the polar regions. So if you do anything over the top of the Earth, there's essentially no data. And even where there was way more data than with the ground-based ionosons, it was still kind of sparse depending on the time of day. And so we needed a different radio source, and last September we went to the Cosmic 2 working group meeting.
And I met someone who talked about GloTEC, Global Total Electron Content, and it's a way better source of data for the ionosphere maps.
Yep, and so about a month later we started working with that. And everything we're going to show you from here on out was done with LLM, or large language model, code generation prototyping. And so we took Hammy's code, we fed that into an LLM, we fed in the maps and the data source, and said, okay, proof of concept, let's do an F2 height map. And within about an hour, we had this. And so you can see that, yep, it looks good. GloTEC has very uniform data because they model where they don't actually have measured data. And also you can see the height of the ionosphere going up and down there. But we didn't want to have to zoom in all the time, so the next thing we did
was ask for ChatGPT to color code it, and it worked really well. We could see what was going on without zooming in with purple at highest and that stuff.
Yep, so at a glance we could see that the lavender color was the highest height, black was the lowest height, and we could see what's going on. So that got us to F2 heights, and the next step was, well, we want to know this critical frequency, the maximum frequency that you can skip a signal at. And so it made more sense to have that just transparent on the Earth, again in different colors, so you could tell relative frequencies. And so that was another about hour, 2 hour exercise with ChatGPT, and it spit out the CZML and JavaScript and the template that drew the maps of the critical frequencies.
But that was nice and all, but we're all scientists here. We need numbers, and so we asked ChatGPT to set out a legend, and it took the range of the colors, put out the legend.
Cool. And so then we had the entire map. So we've got our critical frequencies. You can see a QSO going there in the background, and we know what the height of the ionosphere is at every point. We can actually scale the QSO paths, or the radio contact paths, so that their apogee is at the height of the F2, where they would have had to skip. we made a lot of other utility tools using Cesium and ChatGPT. And I'm just going to walk you through those. Get to the end. This is a nice one. We had a UI where we could actually adjust the height of the transmitting and receive stations to get those exactly right. And at the end of the day, what we wound up publishing was for free, was the NOAA data. This visualization, we use ChatGPT, we use GitHub, Blogger, and Cesium. And every 10 minutes, there's a map that updates with all the ionosphere data. Thanks.
And
That's it.
cool.
Thanks.